This is a brief video in which I will attempt to show you something I learned about 5 minutes ago, maybe 10, how to make a table to calculate limits in Desmos. So what we want to do is calculate this limits from the notes from Monday, and I want, instead of using a calculator for that, to use Desmos, which obviously is something you might be familiar with. So there's two steps to this. The first is I need to make that expression. And the second is I need to make a table that plugs numbers into that expression. So to define this expression, when you start typing in Desmos, these are functions. And I think I need to give this a name because I'm going to need the name of it. I don't want to use S because S is part of it. I'm just going to use F. And the variable is t, so f of t equals. So I made a name for my expression. I want a big fraction here. You can either just type the slash key on your keyboard, or you can pull up this thing and type the division key, and it will set you up a fraction. You don't need lots of parentheses to enclose a numerator or denominator if you type the slash first or go to the division sign first. And I'll just type what it says. 4.9 times, and then 3.2 to the second power, which you can do with a caret, the up arrow sort of thing, or you can just do the second power down here, minus 4.9, and I want t squared, so I type the t and then the squared. That variable has to match, and I'm using t because it makes sense to me to use the variables in the problem. Then arrow down to the denominator and 3.2 minus t. Now it's going to automatically graph for me. I really don't care about the graph. I'm looking for the table. So to make a table, you're going to go to this plus sign and add a table. The problem is I don't really want y1, I want f of x1. So if I put a number in here like 3.0, it's not going to give me the y I want. Go up here and select this and type f of, parentheses there, x1, and it will automatically make the 1 a subscript. And when I hit enter, now this column is going to have values of that function. So when I put in 3.0 again, there's the 30.38 and 3.1 and 3.15. You'll notice actually it started, after I did the 3.1, it said, don't you want 3.2? I really don't. 3.15, so it tries to help you out. It doesn't always get it right. All these match. If I go 3.199, and that's exactly what I expect to see. 3.2 gives me undefined, which makes sense because that denominator, if you put in 3.2 for t, turns out to be 0. That doesn't, of course, mean the limit doesn't exist, and that's why we study calculus. But I hope this is useful to you.